Hey, how's it going? My name is Shri. I'm currently applying to be an IA for EECS 203, and I'd like to go through one of the practice exam questions to kind of show how I would guide someone through approaching it and the way to solve it. Starting off with the proof that we're actually tackling, we're trying to prove or disprove the following proposition. That is, there exists a positive integer n for which 2n cubed plus 4n plus 3 is prime. We have some hints about how to prove and disprove, but just before we even start, we got to understand that the nature of prime, modular arithmetic, and kind of some other tools that we have at disposal are going to be important for tackling it. So our introduction to the problem, we have to remind ourselves of the definition of prime numbers. So a prime number is a positive integer greater than 1 that has no divisors other than 1 itself. So that means you can't express primes as 2k or 3k like you might numbers divisible by 2 or divisible by 3, with k being any arbitrary integer and that number next to it being the 2 or the 3, not being anything other than 1 or the number itself. And so the important of factors in primality is that we have, again, a number is prime if and only if its factors are 1 in itself. And so in the way that we've been taught in EECS 203, we can kind of think it through in a there exists proposition. So if we're disproving that a number is prime, there exists a k and an x such that y is equal to kx, where that's not the number y and 1 itself. Going further from this, we have modular arithmetic and the role that kind of has in this proofs. So modular arithmetic kind of simplifies these complex expressions by focusing on just the remainders after division. And so it's really useful for looking at the divisibility properties and also the parity of a bunch of these expressions. And as we will get into later with some intuition about disproving, we kind of get some guidance on how to approach it through modular addition and modular multiplication. So if someone were to ask, how do I approach it? Well, the first thing I would say is put in some test cases for n. Try to figure out what you're working with. For example, if we have n equals 1, we have 9, which is not prime. N equals 2, we have 27, which is also not prime. And you might start to see a pattern about everything being divisible by 3, which kind of should add up to us using mod 3 in the future. In the future, like we mentioned, just for a refresher, numbers can be expressed in mod 2 as either 2k or 2k plus 1, this being 0 in mod 2 and 1 in mod 2, and we can kind of use this approach, not in mod 2 but in other mods, to investigate the potential factors. When we actually look at factoring this entire expression, we have 2 times n cubed plus 4 plus 3, and as we see 2, 4, and 3 going into -1, 1, and 0 in mod world, this kind of supports our idea even from before that mod 3 is a good option to reduce a lot of these numbers and get them into something different. A key reminder is that if we prove that number is logically equivalent to 0 mod 3, that's the same as proving that the said number is equal to 3k. And as we mentioned before, if there exists a 3k or some other factor, then we know that that number is not prime, and that's kind of integral to our proof right here. Going through our actual proof analysis, we're disproving that for all positive integers n, it's prime, and our cases are with the remainder being 0, 1, and 2 for any given arbitrary positive integer. Going over case 1, we have the remainder is 0, and then we put it into n and solve just using standard modular arithmetic that we've been taught to find 0 mod 3. Same thing with r equals 1, same thing with r equals 2. The conclusion that we can draw, again, it's basically that since we have this 3k, we have a 0 remainder when we're dividing by 3, this number must be divisible by 3, and thus it cannot be prime. But there is one important case that we do have to consider. There is a prime number that's divisible by 3 and is prime. That's 3 itself. So it's really key that once we go through our domain of all positive integers, we can even start with 1 and see that this value is always going to be greater than or equal to 9. And thus we have that this number is not 3. And that ends up actually finishing our proof because we now have the idea that this number is always going to be a non-prime number that is divisible by 3. And then we have our solution. It checks all of the grading guidelines. I think just an important note is that we avoided some common mistakes by going through it systematically and trying test cases rather than just jumping in without having direction. And so I feel like identifying the patterns of modular test and substituting stuff with mod 3 is really important for approaching this problem. If you go through the disproof, we basically just use testing values and modular arithmetic to kind of convert this preposition into something that we can work with the tools that we had at our disposal. The two perspectives that we're trying to think of is the algebraic perspective that you might see when you see this entire 2n cubed plus 4n plus 3 and the modular arithmetic perspective. I feel like helping students bridge that gap is something that I would really like to do, and something that I think is really important for discrete math, where you got to tie all these connections between different topics. And so, going back to that, bridging between different domains creatively is something that I would really like um, to help students work through, because I feel like having that flexibility in thinking kind of helps you be more creative. It helps you approach these 2 or 3 problems in different ways and kind of grow your logic skills in general. My teaching approach, because of that, is to kind of help students make that first step in problems by connecting concepts from various math domains. A lot of the times, people don't know how to approach problems, and that's their main issue. But I feel like by helping people bridge those gaps between unrelated topics in the way that my mind naturally sprawls out in multiple different ways, is going to really help me in contributing as an IA in 2 or 3. Lastly, I just have some contact information, but that's all for me. Thank you.